So this is a GCSE exam question that a lot of students, thousands it says here, found very difficult in 2015. And I think it's probably simply because there are kind of two topics that are joined together here. There's this quadratic equation that we have to work with down here, n squared minus n minus 90 equals 0, quadratic equation. And students, I think, found that rather strange that was associated with a probability question in the rest of the question, which is the main part of the problem. So as we're working through this problem here, suddenly you come across this quadratic equation, and perhaps a lot of students hadn't seen that sort of thing before, and so they were completely confused and puzzled. They also might have made a few mistakes, but we'll have a look at those mistakes, possible places where you can slip up as we go along. So, what have we got here? Okay, there are n sweets in a bag. 6 of the sweets are orange, the rest of the sweets are yellow. But it turns out that the yellow sweets is not important. It's not going to be important to us, so I'm not going to worry about that. Hannah takes at random anyway a sweet from the bag. She eats that sweet. So that's event number 1. Event number 2 is when she takes at random another sweet from the bag and she eats that sweet as well. And what we're looking at here is this, that the probability that Hannah eats 2 orange sweets is 1/3. So we're looking at these two events producing a 1/3 probability, and that's all to do with eating orange sweets. So if we think about what Hannah's actually done, first of all, she takes at random a sweet from the bag and eats the sweet, and we're looking at the probability that it's going to be orange. Well, there are 6 orange sweets in the bag, and in fact let's just draw this out. So if we draw our bag here and our 6 orange sweets, it must be that let's write A. It must be that in the first event here, event 1, she has a 6 out of n probability that she'll pick an orange sweet. Okay? Now, the likelihood that she's going to pick another orange sweet obviously becomes less, so we're going to multiply our two probabilities. So the probability from event 2 multiplied by event 1, because we're multiplying fractions when we're dealing with probability, and multiplying fractions makes them smaller. So because it's less likely, the idea that we're multiplying those fractions sounds about right. So what actually is the probability that she gets another orange sweet? Well, first of all, we need to realize that if she's dipping into that bag for the second time, the situation is not the same as in event 1. In event 2, there's 1 less sweet. So we can't write out of n. We have to write n minus 1. And already we can see how this is going to form a quadratic equation, because we've got an n term here is going to multiply across to an n minus 1 binomial over here. Okay, now there are only 5 sweets in the bag, so the likelihood must be 5 out of n minus 1, and we're told that the probability is 1 in 3. So that equation there, 6 over n times 5 over n minus 1 equals 1 over 3, or 1/3, must be a rearrangement of n squared minus n minus 90 equals 0. So one of the things, obviously, that we've got to do is get that third out from the right-hand side and put the whole equation equal to 0. We're also looking at these n terms here, and they're in a denominator. In other words, they're underneath the fraction bar. We've got to multiply out so that we remove these n terms from the denominator so that everything is in the numerator. So let's do that in a couple of steps. And we know what answer we need to get, so that's one of the nice things about these show that questions. We need to get this to become n squared minus n minus 90 equals 0. So let's see, what's the first thing we're going to do? Well, I think the first thing that we ought to do is just multiply across. So on the left hand side here, or let's put it over onto the right actually, because that I think is going to, well, it's going to save us space anyway. So 6 times 5 will give us 30 in the numerator, and I'm going to keep this in factorized form at the moment. So n times n minus 1 is going to give us n minus 1. So now what we've got, if I just indicate where we are, we've got this equation here, okay, which is hopefully now going to simplify further to get our n squared minus n minus 90 equals 0. And all we've got to do to produce that, I think, let's just have a look, is multiply both sides by n minus 1 and multiply both sides by 3, because that will get all of these terms out of the denominators and everything into the top of the fraction. So the left hand side multiplied by n minus 1 will just give us 1 times n minus 1, in other words n minus 1. And the 3 will disappear when we multiply by 3. And so on the right hand side we get 30 times 3 gives us 90. So you can see we're much closer now to this n squared minus n minus 90 equals 0. Now we simply have to complete this by subtracting both 90 from both sides. That will get the 0 on the right hand side, and the minus 90 will appear on the left, and multiply out the bracket. So we can say, therefore, n squared, because n minus n is n squared, minus n is n minus 1, n times minus 1 is minus n. Now, subtracting 90 from both sides, minus 90 equals 90 minus 90, 0. There we are, which was what we had to say. We could write, which was to be shown. Okay, so that's completed part A. But if you got that far, you then had in part B a really interesting, fairly straightforward quadratic equation to solve. And a lot of people, perhaps quite rightly, would immediately reach for the quadratic formula. So if you know the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, that's a perfectly good, perfectly legitimate and perfectly sensible way of solving this. However, it does seem to me a good equation to solve using completing the square, and also it will factorize nicely. So let's try both of those and complete part B, first of all using completing the square and then by factorizing. So I'm going to see if I can squash it in here. So by completing the square, first of all I would have to rearrange this. Okay, so at the moment it's in the form that we would need for the quadratic formula, but for completing the square I need to add 90 to both sides again to get that minus 90 over onto the right hand side. So that's the very first thing I do. So we've got n squared minus n minus 90 plus 90, so just eliminating that 90, and on the right hand side 0 plus 90 will give us just 90. So that's rearranged it so that minus 90 has come over to the right hand side and changed its sign. Now for completing the square, if I just illustrate this, because I think that people rarely do this, but I think it really does clarify things. If I draw a grid here, okay, and I'm going to I need to make it into a square here, because completing the square isn't about a rectangular grid, it is about making, there we go, let's just erase that then. It is about making a perfect square. There we go. Hopefully that's clear enough. And to fill in these terms into the square, we know we're going to have an n squared here. We don't know what this area here is. That's where we're going to complete the square. Okay. But what we do know is that this must be, we can fill in straight away, n times n. So we must have n as our first term. And our second term, well, that's going to be half of this middle term. In other words, minus half n, because we've got two of them. They're split into these two quadrants here, so we've got minus half n and minus half n here. And that gives us our second term, because n times minus a half will give us minus half n. So on both sides we've now got n minus a half. Okay, now to complete the square. Well, completing the square is about what will be added, though, if we square 9 minus a half. Well, what will be added is a minus half times minus a half. In other words, let's do this in a slightly different colour. There we go. In other words, minus half times minus half, positive 1/4. So that's that little extra that we add when we complete the square. Okay. So that gives us our rearrangement, and as long as you practice with this, it's fairly automatic, fairly straightforward. We end up writing this n minus a half in brackets and squaring it, but realize that by doing that, we've added a quarter that we didn't have before. So on the right hand side, it must be 90 1/4. Well, immediately I'm going to want to join those together. So 90 is actually 360 quarters or 360 fourths. So plus a quarter must be 361 fourths. And these are nice terms because I can see that 361 is the square of 19. So it helps to know your square numbers. And 4 obviously is the square of 2. So we just need to square root both sides, and we end up with n minus a half on the left hand side, and on the right we either have positive or negative, remember if we're square rooting, 19/2. Now I know that it's actually going to be the positive 19/2 that I'm going to want, because a negative is going to be meaningless. It's not going to make sense in the context of the problem. So my next step is going to be to add half to both sides. So I'll end up with n equals, because I've just eliminated that minus half, 19 halves plus a half, or minus 19 halves plus a half, which will give me minus 18/2, and that doesn't make a lot of sense. So the answer has got to be n equals 19 halves plus a half, 20 halves, equals 10. So the value of n is 10. 10 what? 10 sweets in the bag to begin with. Okay, so that's my answer for part B, 10. And let's just see if we can factorize this equation and see if that works out to the same solution. Okay, but my answer is 10, and I wouldn't, if I'd got this far, obviously I wouldn't need to go any further. I've answered the question, and so I need to move on. But let's try factorization, and that will at least verify that the 10 is the correct answer. So how would we do that? Well, if we want to factorize n squared minus n minus 90 on the left hand side here, then it makes sense to use a method to do that. You could just try and do it by trial and error, but I like to be systematic, and so what I'm doing is drawing a little X to organize my working here, and looking at that expression. Well, the minus n, or minus 1 here, is what we've got to end up with. Okay, so we need minus 1 as the sum of those two quadrants. So minus 1 is the sum, and minus 90 times 1, 1 times minus 90 is the product. So minus 90. So what product pairs of minus 90 are going to also sum to minus 1? Well, obviously if we just start with 1 and it would be minus 90, so the minus is going to be the left hand side. That's going to be a long way off our 1 difference. So we've also got 2 and 45. What else have we got? 3 and minus 30. But we're still a long way off minus 1 as being the difference. 4's not going to work. 5, 6, 7, 8, 9. Well, actually 5 is one of the factors of minus 90. That would give us minus 18. But yeah, it's going to be 9 and minus 10. So there we are. 9 times minus 10 will give us minus 90, and 9 minus 10 will give us minus 1. So let's just draw a little grid so you can see what's going on. It's not essential, but I think it's quite nice to illustrate these things. So what we've got now, there we go, and this isn't a perfect square, is we've got our n squared here, our minus 90 here, and what we're saying is we've got a minus 10x and a plus 9x, and then so that's how our two middle terms are going to split to give us our minus, not x, n. Apologies for that. Okay. So as I say, I wouldn't usually go to write this out so laboriously, but it shows you, I think, very clearly now what's going on. All right, so let's now factorize. So let's write it out again. N squared minus n minus 90 equals 0 is the same as, or identical to, n minus, let's do minus 10 first, minus 10 times n plus 9 equaling 0. And using the zero product property, in other words, that if two terms multiply to equal 0, then one of those terms at least must be 0, then you can simply work out the two solutions. So we've either got n minus 10 equals 0, or n plus 9 equals 0. And we're looking at this one because in this solution n would equal minus 9, which was our negative 18 over 2 over on the right hand side here, which we also we disqualified. So, but here we've got n, therefore n equals, add 10 to both sides, and we've got 0 plus 10, in other words 10. So 10 sweets in Hannah's bag, and it doesn't ask us for this, but if it had asked us how many yellow sweets there were, obviously we could have said there are 4 yellow sweets to begin with. Okay.